It's hard to believe, but 2 years have already passed since NASA's James Webb Space Telescope unveiled its stunning first glimpse of the deepest corners of our universe. The $10 billion telescope, the largest and most powerful ever launched into space, has allowed us to peer farther than ever before, revealing incredible secrets of the cosmos. Among its most jaw-dropping discoveries was the revelation of astonishing new details about Mercury, a planet that has long intrigued scientists and captured imaginations. These revelations were so groundbreaking, in fact, that they sparked swift action from NASA to explore this small, but extraordinary world further. Mercury is anything but ordinary. Orbiting perilously close to the blazing heat of the Sun, this small planet's surface is not just a barren wasteland, it glimmers with unexpected treasures. Among its most intriguing features is the discovery of diamonds, scattered across its surface. Yes, diamonds, on a planet where temperatures soar to more than 800 degrees Fahrenheit during the day. But this dazzling surface hides even more mysterious qualities, qualities that challenge everything we thought we knew about planetary science. Beneath the shimmering facade of glittering diamonds lies an oversized, enigmatic core that doesn't fit the patterns we see elsewhere in the solar system. What other secrets could Mercury be hiding? And what more can we learn about this strange world that might change our understanding of planets as a whole? Despite its small size, Mercury has been the subject of many remarkable discoveries. For years, scientists have been piecing together the puzzle of this fiery world. Recent probes have uncovered more jaw-dropping facts. Beyond the diamonds, scattered across its surface, Mercury holds yet another mystery, its core. The planet's core is unusually large for a planet of its size, and it's composed of material unlike what we've seen on Earth or any other nearby planets. These revelations force us to ask, what makes Mercury so different? Why does it possess these extraordinary features? What hidden aspects of Mercury remain to be discovered? Our understanding of Mercury began decades ago with the Mariner 10 spacecraft, which in the 1970s gave us the first close-up images of the planet. These images revealed a harsh, rugged landscape full of craters, ridges, and valleys, a terrain eerily similar to the Moon's. These findings were groundbreaking because they challenged our previous assumptions. We learned that Mercury wasn't just another tiny, unremarkable rock. It had a dynamic, surprising surface and, most notably, a magnetic field, one far stronger than scientists had anticipated given the planet's small size and slow rotation. But these were only the first hints of Mercury's larger secrets. In 2011, NASA's Messenger mission returned to Mercury, but this time, the spacecraft didn't just fly by, it orbited the planet. This allowed for years of detailed research and provided a treasure trove of data that has completely transformed our understanding of this enigmatic world. Messenger captured more than 200,000 images of Mercury, showing regions that had never before been seen, and provided a treasure trove of data that revealed new complexities about the planet's surface and interior. For example, scientists found unusual concentrations of calcium and magnesium on Mercury's darker side, an enigma that sparked a wave of curiosity about how these elements ended up there, and what kind of natural processes were responsible for their distribution. Even more surprising were findings related to Mercury's magnetic field. Unlike Earth, where molten iron in the core generates our planet's magnetic field, Mercury's field is generated by a much more complex process, possibly due to a unique combination of its internal structure and rotation. This was completely unexpected and raised a whole new set of questions. How does Mercury's core function differently from Earth's? What does this mean for our understanding of how planets generate magnetic fields? One of the most intriguing findings from Messenger was the discovery that Mercury experiences extreme temperatures. This should come as no surprise, after all, Mercury is the closest planet to the Sun. But what scientists discovered goes beyond what we might have imagined. Daytime temperatures on Mercury's surface can reach a blistering 800 degrees Fahrenheit, hot enough to melt lead. At night, however, the temperatures plummet to a bone-chilling -292 degrees Fahrenheit. These extreme swings are due to Mercury's near non-existent atmosphere, which offers no insulation to protect the planet from the sun's intense heat during the day or to keep warmth in during the long nights. But what's truly remarkable is that these temperature fluctuations aren't the planet's most baffling feature. In 2012, MESSENGER data uncovered evidence of ancient volcanic eruptions and signs of volcanic activity on Mercury, challenging the long-held belief that the planet had long been geologically dead. This was a revelation, as many scientists had assumed Mercury was an inactive world, devoid of tectonic processes. To find volcanic activity on a planet that is so small and so close to the Sun defied previous expectations and opened up new questions about Mercury's geological history. Then, in 2020, a discovery made Mercury seem even more perplexing. Despite its proximity to the Sun, scientists discovered evidence of water ice in Mercury's permanently shadowed polar craters. These regions, which are shielded from sunlight, are cold enough to preserve water ice, even on a planet so close to the blazing sun. This surprising finding raised questions about the potential for life on Mercury. Could primitive forms of life exist in these cold, dark zones? It's a fascinating question that not only changes how we view Mercury, but also opens up possibilities for life to exist in extreme environments elsewhere in the universe. Yet the story doesn't end there. In 2018, a new collaboration between the European Space Agency, ESA, and Japan's JAXA launched the Bepi-Colombo mission, designed to study Mercury more closely than ever before. The spacecraft is scheduled to arrive at Mercury in 2025, and it will provide a wealth of new data about the planet's surface, core, and magnetic field. Bepi-Colombo is equipped with advanced instruments to examine the planet's mineral composition, study its atmosphere, or lack thereof, and unravel the mysteries of its geological history. The mission will also explore the strange magnetic field that Mercury generates and how it differs from those of other planets. Perhaps the most astonishing feature of Mercury, however, is that its day lasts longer than its year. In most planets, a year, the time it takes to orbit the Sun, lasts longer than a single day, but not on Mercury. A full year on Mercury only takes 88 Earth days, but a single day, one full rotation on its axis, takes about 176 Earth days. This means that a day on Mercury is twice as long as its year. And because of this odd spin-orbit resonance, the Sun appears to pause and even reverse its path across the sky before continuing again. This strange phenomenon happens because of Mercury's slow rotation in relation to its orbit around the Sun. The planet's unusual motion creates extreme environmental conditions, with one side facing months of blistering heat, while the opposite side is plunged into long periods of bone-chilling cold. This slow rotation is the result of tidal locking, a process in which the Sun's gravity has gradually slowed down Mercury's rotation over billions of years. Mercury follows a 3-to-2 spin-orbit resonance, meaning it rotates 3 times for every 2 orbits around the Sun. This odd pattern results in extreme temperature variations across the planet's surface, where one hemisphere swelters in heat while the other remains frozen in darkness. The areas in constant darkness at Mercury's poles have proven to be prime candidates for finding ice and, potentially, other hidden compounds. Mercury's atmosphere, or, more accurately, its exosphere, is another mind-boggling feature. This exosphere is incredibly thin, consisting of particles that constantly leak into space. It's replenished by solar wind, impacts from meteoroids, and radioactive decay from the planet's surface. In 2020, data from the MESSENGER spacecraft revealed that the amount of water vapor in Mercury's exosphere was much higher than previously estimated. This discovery points to a fascinating chemical reaction in which oxygen from the planet's surface interacts with hydrogen from the solar wind, producing water vapor. Perhaps one of the most unexpected discoveries was Mercury's strong magnetic field. Given its small size and slow rotation, scientists didn't expect Mercury to generate a magnetic field at all, but it turns out that it does. While weaker than Earth's, it's still powerful enough to shield the planet from the Sun's fierce solar wind, preventing the exosphere from being stripped away. Despite its close proximity to the Sun, Mercury's fast orbit and slow rotation present serious challenges for space missions. Getting a spacecraft into Mercury's orbit is no easy feat. Missions like Bepi-Colombo rely on complex flybys, using the gravity of Venus and Mercury itself to gradually slow down and adjust the spacecraft's trajectory. The Bepi-Colombo mission is expected to arrive at Mercury in 2025, after completing a series of flybys and adjusting its path over the course of several years. Studying Mercury's volcanic history, core composition, and magnetic field is crucial to our understanding of the solar system's evolution. Each new discovery about this mysterious world is like opening a new chapter in the story of our cosmic neighborhood. With missions like Bepi-Colombo on the horizon, we are only just beginning to unlock the many secrets Mercury holds, secrets that could ultimately provide fresh insights into